So now we'll talk about the rotational Raman spectra. So first we'll talk about the linear molecules. Okay, so the equation we have to calculate the energy levels will be B J into J plus 1 centimeter nodes. So this is very important. So on this problem we'll get many problems in examination point of view, and one more principle we have, that is delta E rotational is equals to B 4J plus 6. So these two are very important. You have to remember these two equations. So there are many problems which they have asked in examination point of view. So I have collected those questions, so I will be making a separate video on these problems. So here I want to explain about the theory, what is involved in the rotational Raman spectroscopy. Like so why we are calling it is a rotational Raman spectroscopy. So we know that what is a Raman spectroscopy means, like so there should be some change in the polarizability ability, or we can say that a induced dipole moment. After we get induced dipole moment, then we say the molecule is polarizable. Okay, so in the rotational Raman spectroscopy we are bringing this polarizability by rotating the molecule. So here we are just rotating the molecule. By rotating we are bringing the we are making the molecule into polarizable molecule. So that's why we are calling them as a rotational Raman spectroscopy. And so in the rotational spectroscopy, the selection rule delta J equals to plus or minus 1. Okay, but in the rotational Raman spectroscopy, the selection rule delta J equals to 0 and plus or minus 2. So when the selection rule, this will be useful. So for what this plus or minus 2, now I will explain. So when the incident radiation as well as scattered radiation is same, that time the delta J equals to 0 selection rule will be applicable, and this is for the Reliant scattering. So delta J equals to 0 is for Reliant scattering, and delta J plus or minus 2 is for the Stokes and anti-Stokes lines. But as we can see in the rotational spectroscopy, delta J equals to plus or minus 1. But why in the rotational Raman it is a plus or minus 2? So we know that when we have a one substance or molecule, so we are there is a collision with a proton which is having energy of h nu. Okay, and after some time they goes to the virtual state, and then the radiation will be scattered, that will call h nu bar. Okay, now here two dipole transitions are associated. Okay, so one is for the incoming proton, another one is for the outgoing proton. So total two dipoles are associated. Means when yeah, when incoming proton is coming for collision, so that time in the virtual state this will deform. I means the shape will change, this one in the virtual state, and while scattering again the shape is changing. That means it involves two dipole transition, means two times induced dipole moment is produced, or we can also say that two times it get polarized. So one time when this incoming proton comes, another time when outgoing proton scattered. Okay, so that's why there is a two quantum rotational jumps will be there. I mean, I'm trying to say that 0 1 2 two rotational quantum jump means 0 to 2, this one. Okay, so plus or minus is 2, plus or minus 2 is for the Stokes lines and anti-Stokes lines. I hope this concept is clear. And now how we will show delta J equals to plus or minus 2. So when you are saying delta j is plus or minus 2, that means the transition from j to j plus 2 or j plus 2 to j. Okay, so this is for Stokes and this is for anti-Stokes. This is also very important. When we discuss the rotation Raman spectra, that time these transitions are very important and the selection rule also very important. Now, so the energy of rotation can be written as B 4j plus 6 centimeter inverse. Okay, so this is the rotational energy change. Now, so this also can be written as delta nu bar rotation equals to B 4j plus 6 centimeter inverse. Okay, and the wave number for Stokes and anti-Stokes, there is one relationship. That relationship is plus or minus delta nu bar equals to nu bar minus nu dash bar. Okay, so this relationship which comes from, I think it comes as a Raman shift or something. So this is the wave number relationship for Stokes lines and anti-Stokes lines. So now we will substitute this equation here, then it will become nu minus nu bar equals to plus or minus B 4j plus 6 centimeter inverse. So here plus del nu rotation, so this is for anti-Stokes, and plus minus del nu rotation, this is for Stokes lines. Okay, so I hope everything is clear here. For linear molecule we are discussing first. So in the Raman spectroscopy means the molecule should get polarized. So molecule get polarized when, so when there is some induced dipole moment, in that case only molecule gets polarized. So in case of rotation, we have selection rule delta j equals plus or minus 1, but rotation Raman spectra we have selection rule delta j equals 0 and plus or minus 2. So this delta j equals 0 when it's applicable, that is for the Reliant scattering. In that case the incident radiation and scattered radiation both will be same. And for Stokes and anti-Stokes lines, the selection rule is plus or minus 2. So this will here two photon change will be there, so 2 times molecule get polarized, so that's why we have selection rule plus or minus 2. So and then we have j to j plus 2, this is Stokes lines, j plus 2 to j, this is the anti-Stokes lines, and then this one. So now we'll go for the rotation Raman spectrum. So this is very very important, and on this spectrum the questions will be asked. So here we have to use the two principles. The first one is delta E rotation equals to P 4j plus 6 centimeter inverse. If j equals to 0, then it will become B 0 into 4 plus 6, this will be 6 beta. When j equals to 1, this will become 10 beta. Then when j equals to 2, that time it will become 2 into 4 plus 6, 14 beta. So sorry, not beta, B, like that, 20b and 22b. Okay, and these are the coming from this one. And similarly we have another principle, that is Ej equals to Bj into j plus 1 centimeter inverse. So when E equals to j equals to 0, that time it will be 0 centimeter inverse. For E1 this will be 2b centimeter inverse. For E2 this will be 6b centimeter inverse. For E3 this will be 12b, like that, 20b, 30b, and 42b. Just substitute here, this comes like 2 into 2 plus 1, sorry, 1 into 1 plus 1, this will be 2 beta, and here it will be b, 2 into 2 plus 1, 3 2s are 6, like that we have energy states. So now we'll go for the spectrum. So this is the 0. As we go up, the energy difference will increases. This is 2b, and this is 6b, this is 12b, 20b, 30b. So as we go up, the energy difference is increasing. So we know that Stokes lines means the transition takes place from J to J plus 2, and anti-Stokes means transition takes place from J plus 2 to J. Now here the transition from 0 to 6, then 2 to 12, then 6 to 20, then 12 to 30. So why there is no transition from 0 to 2? So I have said already, there is a 2 quantum of photon is involving. That means two quantum rotational jump will takes place. That means instead of here, this goes here. Okay, so whatever I said here, I have explained this here. Here I said 0 to 2, so this means there, because of plus or minus 2, there is a 2 proton is involved, 2 quantum of rotational jump will takes place. So this is for the Stokes lines. And for anti-Stokes lines, as we can see here, j plus 2 to j, that means from here to here, and from here to here, then here to here, and this here to here. So this is for the anti-Stokes lines. This is anti-Stokes lines, and this is the Stokes lines, and the overall spectrum looks like this. So this is a Reliant scattering, so delta j equals to 0 here. Okay, so now this will be 1, 2, 3, 4, 5, and similarly 1, 2, 3, 4, 5. So this will be a transition from 0 to 2. We can make this 0, 1, 2, 3, 4, 5. So we can make this energy state 0, 1, 2, 3, 4, 5. So like that, if you see here, I think it's clear. Wait. I hope everything you can see. So whatever here we are representing 0 to 2, that is this transition, and this will be 1 to 3, that is from here to here, and this will be 2 to 4, that is this to this, and this will be 3 to 5, and this will be 4 to 6. Okay, that I have not shown here, but just remember one more line here, and then 4 to 6. And similarly here we have, so this is from j to j plus 2, and this will be j plus 2 to j, and it will be a reverse. So this will be 2 to 0, and this will be 3 to 1, 4 to 2, and 5 to 3, and 6 to 4. Okay, now so this will be 6 beta, 10 beta, 14 beta, 20 beta, and 22 beta. So just remember, before I said the anti-Stokes lines means negative. sorry, Stokes lines means negative, anti-Stokes lines is positive. That means this all will be negatives, negative values, and this will be positive value: 6 beta, 10 beta, 14 beta, 20 beta, and 22 beta, like that. So now see, the difference between the two energy state will be a 4 beta. Anywhere you just take, I think this is 18. Okay, this is 18. So the difference between the two Stokes lines or two anti-Stokes lines will be different. These are very important. Difference between two Stokes lines, two Stokes lines and two anti-Stokes lines will be a 4 beta centimeter inverse. In examination point of view, this is very important. And the difference between one Stokes and Reliant will be a 6 beta. So this will be 6 beta because this is 0. So 0 to 6, I think you can see. So this is 0 and 0 to 6 difference is 6 beta. That's why the difference between the Reliant line and first Stokes lines will be 6 beta, and here also same, because this is 0, this is 6 beta. And now this is very important. The difference between the first Stokes line to first anti-Stokes line will be a 12 beta. 12b, because so we are talking about this line and this line. So from here to here 6 beta, and from here to here 6 beta. Total how much? 12 beta. So these 3 points are very important. So the difference between the two Stokes lines and two anti-Stokes lines will be a 4b, and the difference between the first Stokes lines or first anti-Stokes line and Reliant line will be 6b, and the difference between the first Stokes lines to first anti-Stokes line will be a 12b. Okay, and now so delta J equals to plus or minus 2. That means we can write it as a delta J equals to plus 2 plus 1 0 minus 1 minus 2. So when we have a plus 2, this will be S branch. So just remember this will be S. Next we have R, Q, P, O. This alphabet O, P, Q, R, S. Okay, like that. If they are given delta J equals to plus 2, that is comes under S branch. If it is minus 2, that comes under the O branch. So I hope this diagram is clear. So I have said why two rotational energy jumps are taking place, because of two quarter proton is involved, and this is for Reliant line, and these energy states we are giving basing on the principle J into J plus 1. Now I think 4J plus 6B. By using this principle we are giving these energy states. And now we are talking about now we are going to talk about the nuclear spin. So this is also very important. So now we are going to talk about the oxygen, CO2, nitrogen and H2. Okay, so these two are nuclear spin inactive. That means the nuclear spin is 0, and here nuclear spin is not equals to 0. For them, how this rotational Raman spectra, so rotational Raman spectra will looks. So I'm going to explain these things in this diagram only. I hope it will be like it will not be much. Okay, if possible, if it's required, I will make one more same diagram so that it will be easy. No need to get confusion.